So we're going to be entering into our chapter on lipids, which is probably a lot of our favorite molecules, whether we realize it or not. So we're going to start with talking about what are lipids, what makes a molecule a lipid, as opposed to a monosaccharide, which we just learned about, or a protein or a nucleic acid, which we'll be learning about next. So let me start by just putting up some structures. I have some ball and stick models, and then even just a line formula of some lipids. So taking a look at those, take a moment to just what do you notice about them? There's a couple things that I notice. If I'm assuming black is carbon and white is hydrogen, then it's mostly hydrocarbons. We got mostly just carbon and hydrogen, and that tells me a couple things about it. You know, it's going to be largely nonpolar. It's going to probably store a lot of energy, just because we know that those organic compounds, they're highly combustible. It's even one of the definitions of organic compounds in the first place. I see very little of others. I'm assuming oxygens. You'd have to look that up to know. But beyond that, I actually don't see a lot other similarities. They're very, very different. Here we have multiple cyclic structures, like these little rings in them. Here we have one ring. So I have 1, 2, 3, 4 rings over here, one ring, no ring, no ring. It just kind of bends over itself. They're all fairly large. So what I'm trying to demonstrate here is lipids are really diverse. They're a very diverse group, as opposed to our carbohydrates that we just looked at, which really can all be defined by some similar and related functional groups. They're all polyhydroxyl aldehydes or ketones or substances that can be hydrolyzed into those. And we don't get any such definition with lipids. Lipids do not necessarily all have an aldehyde group or a carboxyl group. So their functional groups aren't necessarily the same. You can see their structures can vary widely, which means their functions are going to vary widely, since structure and function are often related. So what makes lipids all similar? What do they all have in common so that we have that similar classification system? It is that they are soluble in nonpolar solvents only. So that's not a huge area of overlap. They're the biological compounds that are only soluble in nonpolar solvents. So they are only soluble in nonpolar solvents. So imagine you took an organic structure and you ground it up, we won't get gruesome, think a plant or something instead of a hamster. We ground it up and we ran an organic solvent through it, something like hexane, something highly nonpolar, so a nonpolar solvent. What we would collect, because all the nonpolar stuff would go with it, everything we would collect would be classified as a lipid. And that's why we get such diverse groups. And that means we're going to see really diverse functions because we have really diverse structures. Really, the idea that they're only polar and nonpolar solvents is the thing that makes them all classified as a lipid. And so you're going to see a big diversity in their functions. So let me put up that function list and just take a second to read it. So some things I want you to notice is we've got energy up there. So lipids are in a lot of our food, and they do pack quite a punch. They pack significantly more energy than the other organic families that our body can use for energy, such as proteins and carbohydrates. So that makes them a great energy source and then a great energy storage. So we learned in the last unit that we can store energy for in glucose form of energy in glycogen, but we really only have a few hours worth of glycogen stored up. We need, because there could be much longer periods of time without food, we need an energy storage system that's better than that more than just a couple hours, and that's where our lipids come in. So structural components in cells, chemical messengers, particularly in hormones and prostaglandins. Some of our vitamins are lipids, and therefore some of those vitamins need to be carried. If you've got a nonpolar vitamin, it's got to be carried through something that is also nonpolar, so carrier of lipid-soluble vitamins. And then kind of my just personal favorite, shock absorption and insulation. So I like to just think, I'm not really getting chubby, I'm just ready for a fall. So we're going to be looking at classifying lipids, and there's really lots of different ways that we can classify them, and this is kind of one of the, we're going to look at the way the book is, and we'll kind of follow that. But if you research it online or look up in other resources, you might see a slightly different classification system. So lipids, we know all are only soluble in a nonpolar solvent, so they're all going to have that in common. And we're going to look at three main categories. So we're breaking all of those lipids, all of them, into three main categories. So fatty acids, which we've actually already really learned about, which is really nice because it's just really then a review. Our fatty acids, you might remember, are long chain carboxylic acids. So they have that carboxyl functional group, but their R group is just really big, a really big hydrocarbon group. And if we went back to that earlier slide, you might be able to find the fatty acid in there. So that R group might be like, 20 plus carbons long. We then can classify them based on whether or not that R group is saturated or unsaturated. So this is all about the R group. Right. We're also going to learn, it's not really a fatty acid, but it's derived from a very particular fatty acid. So I'm going to kind of put it under. So I will say can make. We're going to learn a little bit, just a little bit about prostaglandins. That was another one that I had on that main page. So they're not technically a fatty acid, but they're all derived from one particular fatty acid. And so I kind of think of them as belonging up there. So then we have fatty acids, and then we have glycerides. And so glycerides are lipids that contain a glycerol backbone or subunit. So sometimes we'll even just say contain glycerol. I have to be really honest, I hate that. I just don't like it. So I like to say glycerol like subunit or something, or backbone, because glycerol doesn't actually exist in those molecules before. So you might remember from a previous unit, glycerol is the common name for a triol. Specifically, it is 1,2,3 propane triol. So it's just a 3-carbon group where every single carbon also has a hydroxyl group. Now, when glycerol reacts to form these lipids, those hydroxyl groups really aren't there anymore. And so that's why I'm like, well, they don't really contain glycerol, but they do contain a backbone or 3-carbon portion that is derived from that glycerol. So you can totally say it contains glycerol and I'll forgive you. I just don't like that language, but I don't get to choose. So these are ones where we're going to see that 3-carbon backbone and those 3 hydroxyl groups might have reacted with other things. And we get our neutral ones, meaning they have no overall charge. And that's really going to be our fats and oils. Or if we wanted to get fancy, these would be our triglycerides. So you can even hear the glyceride in the name, triglycerides. They have that, and we've talked about these before too, when we learned about saponifying, because you can saponify a fat or oil to make soap. So some of this will feel like review as well. So our triglycerides, ones that are not neutral because they're going to have a charged portion coming from a phospho group are our phosphoglycerides, which some people just will call phospholipids. So they're not neutral because that phospho group, so phospho comes from that idea of phosphate or phosphoric acid. Oh, I never get this right. Sorry. Ignore that double bond right there. That phosphate can donate these protons or react, and then we're going to get charges there. We're going to get charges on these. And so we're going to have a charge in that as opposed to our neutral ones. And then non-glyceride lipids. What do you think that is? Those are ones that do not have this. They're not fatty acids, and they do not contain a glycerol backbone or subunit. So no glycerol. So that's a pretty big category when you think about it. Like the definition being that they do not contain glycerol. So those, we get our sphingolipids, which that name just comes from a really particular compound of which they have or are derived from. Our steroids, such as testosterone and estrogen and cholesterol, and then waxes, like the protective coating on some fruits. and even just like, your earwax. So quick review questions. I'd always encourage you to pause the video in such a case and try to answer them yourself before you proceed. Which of the following is not a function of lipids? It is B, enzyme catalysts. They are structural components of cell membranes. They are a major energy source, and then we store them in fat or adipose tissue for long-term energy storage. So we're going to find is enzyme catalysts. These are going to be, we're going to learn about these more with our proteins. Enzymes are biological catalysts, and they are derived from proteins. What do all lipids have in common? Well, they don't all have glycerol, so it's not that. They don't all have a carboxylic acid portion. Right? They don't all serve the same function. They are all only soluble in non-polar, non-polar solvents. So they might have a couple polar groups, but their hydrocarbon, they're going to have so many more non-polar portions that it outweighs it. So they're really largely non-polar. So even if they might have like 1 or 2 little oxygens, it's not enough to compensate for the non-polar portion. So they're only soluble in non-polar solvents.